In the previous video, we had completed part A of the circular motion problem involving Newton's laws, and now we were left with part B, which says find T, which was the period, not the tension in the rope, the period. We knew that the speed is equal to 2 pi r over the period, and we had found the speed. We also know the radius in terms of the length of this rod, which was 5 meters, and an angle which was 30 degrees. So we just need to finish by rearranging this equation. T is equal to 2 pi r over V, which is 2 pi L sine of 30 degrees over V. But the sine of 30 is 1/2, so this is 1/2. And 1/2 times 2 will cancel, and so I have pi L over V. So this is pi times 5 meters over 3.76 meters per second. So the time is going to be just a little less than 5, because pi is a little smaller than 3.76. So we punch our calculator, 5 times second pi divided by 3.76. And assuming that I've done all the calculations right, it's about 4.18 seconds. Now, there's several interesting things about this ride problem. So let's talk about what we found. We found that the mass was irrelevant in the problem. This is why they don't have to weigh you or know anything about it to figure out. The second thing is this thing takes 4 seconds to go, but it turns out it's not a very big circle that it's going around. The total distance across it, the r here, is 5 times the sine of 30. The radius is only 2.5 meters. That means the diameter is only about 5 meters. This is about 15 feet. So this is a completely impractical from an amusement ride, because the circle's not very big. You couldn't get very many people there. That means you couldn't make very much money for the time you have. These are the sort of issues the engineers think. Okay, the money and the bolts. They're not doing the original development. That comes from the physicist, but they are concerned about how to make the device so that you can get more people on it, make more money, so forth. Different people have different interests, and depend on their interests, it'll depend what they choose to major in. So anyway, that's what this problem is. Nothing really special about the problem. That's the key. Circular motion, or central force problems as we call them, are one of the standard problems that physicists can solve, and there really isn't nothing special about them. They're just like any other problem. Just lay your axis along the radius, know that the acceleration along the radius points to the center of the circle, and it's a centripetal acceleration, so you have the magnitude formula v squared over r, and otherwise you just go ahead and you work the problem. All right, we'll do another example in another video.